So, this question is asking, what molecular orbital is used in the light-induced electrocyclization of the following molecule? Well, the following molecule is 1,3,5-hexatriene, and an electrocyclization reaction, that's where you take molecule and the pi bonds react in a cyclic manner to form a new sigma bond for ring closing, or in a case of ring opening, you lose a sigma bond. But essentially, this is an electrocyclic reaction. Now, light-induced, well, that's the orbital that's going to be used to determine the stereochemistry when you have substituents off of these groups. And for light, you want to use the LUMO. If you were using heat, you would use the HOMO. So light, you're going to use the LUMO. So the way to figure out the LUMO, there's a couple ways of doing it. One way is you can order the molecular orbitals in terms of energy. That's based off the number of nodes. So this is 0 nodes here. This has 1 node. This has 2 nodes. This has 3 nodes. This has 4 nodes. This one has 5 nodes. A node, keep in mind, is between two opposite ones. So such as that would be the 1 node there. And then you can count the number of electrons. You have 6 electrons. And so you're going to fill up the electrons up. So here gets 2 electrons. Here gets 2 electrons. Here gets 2 electrons. So these are all filled molecular orbitals. Now the next highest one that's unfilled is this one right here. And so that's the answer. Another way of doing this is you could have started out by drawing the HOMO of this molecule, and that's pretty straightforward when it's an even chain. Just draw in your p orbitals, and where there's a pi bond, you have the same shading. There's not a pi bond between atoms 3 and 4, so therefore we have a node. And you can see that this matches the HOMO. Now for LUMO, what you would do is you take this, and wherever there isn't a node in the HOMO, there will be one in the LUMO. So there's not a node between the first two, so there is a node here. There is a node between these two, so there isn't one here, and so on and so forth. And you can see that this matches that, making that the LUMO. So the answer here on this question is C.